Here we're going to graph this equation and notice that we have a subtraction situation, right? And you see the x is being squared already, and then the y is also being squared already, so we don't have to do anything crazy. And we have the 1 on the right hand side already as well. This is almost in the standard form of a hyperbola because we have a subtraction situation, right? And the reason I said this is almost in the standard form is because we have to look at these two numbers as something to a second power, right? So for the first one, we are going to rewrite it as x plus 2 square over, for the 9, I will put that down as 3 square. And then we are going to subtract. For the second term, we have y minus 1 square over, for the 16, it will be what? 4 square. And then this is equal to the 1 that we need, which it is. That's great. And now, can we graph this already? We need to have the center first, right? So let me just write it down here. The center of this hyperbola, well, the x value is what? This is x plus 2, so we actually have negative 2. And then this is y minus 1, so we actually have 1. So the center is at negative 2, 1. Be sure you do the opposite, okay? And all we need to do now is just to make the graph, right? So let's do it. The center is at negative 2, 1, and let me just do, this is negative 1, 2, 3, 4, 5, 6, and then this is 1, 2, 3, 4, 5, 6, negative 1, 2, 3, 4, 5, 6, and then positive 1, 2, 3, 4, 5, 6, something like this. Center is negative 2, 1. Negative 2 is right here, 1 is right here, so this is good. So for this 3, this is down below with the x. We will associate the x with left and right. This will tell me we have to go to the left 3 times and go to the right 3 times. From the center, move to the left 3 times, which will be right here, 1, 2, 3. And then from the center, move to the right 3 times, 1, 2, 3 will be right here. So these are the 2 points that we have. And then for this 4, it's underneath the y. We associate y as up and down. From the center, we are going to go up 4 times. So 1, 2, 3, 4. It's going to be somewhere here. And then from here, we go down 4 times as well. We go down 1, 2, 3, 4. So we have this. And now, remember, for hyperbolas, we have to draw that imaginary box, right? And let's do it. Right here, I'm just going to connect this 4 points with a rectangle. And be sure you use dashed lines. Okay? And remember, you can always draw the rectangle, and sometimes you have a circle or ellipse inside. Just like how I like to tell you guys, you will have a cake or a pizza inside, right? But in this case, when we have a subtraction, we are not going to have anything inside. And remember this, I'm doing this to you guys to emphasize we are not going to have any circle, nothing inside, because this will help you. Remember, we are going to draw the dashed diagonals. So let's go ahead and do that. So I will just draw the diagonals like this. And all these are just guidelines, okay? Okay, great. And now, final step is to draw the curves. Remember, it's either we have an open left, open right curve, and that's one picture, and maybe an open up, open down curves, and that's one picture. How do we know which one's what? Well, in this case, we have the x goes first, right? This is the x minus y. When we have x minus y, we have the left, right situation. So I'm going to draw the curve right here, and you are going to follow the diagonal lines. Okay, these are called the asymptotes. But then to graph this, I'm just going to connect, okay, just draw it, and be sure the only place that you can touch the diagonal, well, you don't touch the diagonal, but then be sure you touch the vertex here. And then it's almost touching the diagonal. So it's almost touching the diagonal, like this. This is the left branch. And we also do the right one, so it will be like this. Like this. It's almost touching the diagonal, but in fact, the curve will not touch the dash diagonals. So this is it.